Okay, rescuers, welcome to Training Minutes. My name is Dave Dalrymple. Today's evolution, we're going to talk about proper cutting techniques with a power hydraulic cutter. Now, most of you are thinking, Dave, I know how a power hydraulic cutter works. I know he goes up and cuts things. What's the big deal? Well, most of us, when we've learned how to cut things with a power hydraulic cutter, it was mostly sheet metal. And it was a long time ago, because up until fairly recently, our cutters could not cut hardened materials, even hinges or latches. So let's watch as a crew takes a student through how to cut parts of the vehicle with a power hydraulic cutter. Okay, our student's going to go up and start his first cut with a new car technology type of bladed cutter. However, as you noticed, he's on the wrong side of the tool. You never want to be between the tool and the vehicle. Now, one of the things that you'll notice with these new car technology type blades, because of the shape of the blade, and many times the tool will twist and torque on small items or sheet metal. One of the things to try and correct it is to stop, reposition the tool, maybe flip it over to get a different angle to make your cut. Especially if the tool starts to go in a direction you do not want it to go in. Remember, you want to let the tool do the work. You control the tool. You will not be able to force the tool to go one direction or the other. One of the things, as you make your cut, let the tool work all the way. That means even if you think the tool has stopped, let the tool continue to run for a short period of time to make sure the cut is complete and straight through. Whether it be sheet metal or hardened materials such as a hardened reinforcement or hinges or latches. Now, in this particular instance, the student's going to cut a crash beam of a door. The crash beam of the door should be approached at a 90-degree angle, basically at a right angle to what's being cut. And since it is high tensile material, it's going to react violently when it's being severed. Now here the student is going to make a cut on the B-post. One of the first things that you should check is, where is the adjustable seatbelt bracket? 2, the choice of tool that he's cutting with. He's using a combi tool. One of the things to remember, a combi tool will not make a complete straight cut. And also, as it squeezes, it will push away from where it's being cut. Remember, your selection of cutter to what's being cut should always match. You need to think a little bit about where you're cutting and what you're cutting with. If you only have one cutter, then you have to do the best you can. But a combi tool type of cut here on this B-post is very difficult to try and cut. One, the size of it and the shape of it, because it's naturally going to push the tool away. But the other point was the choice of location, because you're trying to cut through the adjustable seatbelt bracket. Now again, because we're cutting through a hardened material, we need to let the cutter work. It's all the way through the cycle. So we need to keep the control handle held until we ensure that the tool is completely stopped. The other part of this cut is, many times, because of the size of the cut and the size of the roof post, you're going to need to approach the roof post cut from different angles and different directions. Now what we're going to show you is we're going to show you the 3 different types of cutters we've used in this scenario today. The first one is a combi tool, which is basically a straight bladed cutter. The second tool is a new car technology type of cutter with new car technology blades. Then our last cutter is going to be a 9-inch UL cutter or an earwig type of O cutter. Now, as you can see from each cutter has dynamics individual to its own due to the shape and size of the blades involved, hence giving them advantages and disadvantages for each type of cut depending on the situation. Okay, when we're cutting hardened things such as crash beams, reinforcements, latches, and hinges, a new vehicle type of blade is optimal for use. So here we're going to cut the hinge and we're going to cut the latch for this door. Now, as you can see, the door skin of this vehicle was peeled off because we tried to do a door pop that failed using a spreader. The tactic of way to go today is to expose hinges or latches with a spreader and then cut them, such as we're doing now. It's much easier, it's much safer for the tool operator, the patient, and it's easier on the tool itself. Most of these cuts you've seen us do today are surrounding cuts, where the actual tool has surrounded the object that's being cut. When we're cutting hinges and latches, we want to make sure our tool blades go completely around them. We don't want the tips to touch the tops and bottoms of the hinge or latch. That will tip load the tool and more than likely break the tool. The other type of cut is a penetrating cut. For example, like we tried to perform with the combi tool on the B post. Again, one of the things to listen for as we make our cut, listen for the power unit. Many times our power units have a second stage. You might think the tool has stopped working, but it's actually moved into the second stage to increase its power. And again, we're going to cut the wires between the vehicle and the door due to the fact that power hydraulic cutters can make static electricity. We want to try and eliminate that by using a hand tool. Okay, rescuers, we just watched our instructors show a student how to cut various components of the vehicle with a variety of different power hydraulic cutters. We cut hardened materials, we cut sheet metal, we cut wide components, we cut narrow components. We also showed you how to use edge protection, sharp edge protection. We showed you how to use proper patient protection. That's going to protect the EMS provider and the patient. I'd like to thank you for watching Training Minutes. I'd like to thank Holmatro for sponsoring Fire Engineering's Training Minutes. Be safe out there.